Welcome to 6.3. So for 6.3 we get to graph some radical functions. Radical meaning that there will be a square root sign in our function. So the first picture here kind of shows you an example of what that's going to look like. It's going to have a starting point and it's always going to curve towards the right. It's never going to go left. Why is that? Well, because there's going to be a point underneath the radical sign where it can't go negative. So for example, this is kind of the very basic, what we would call that parent function that's not moved left, right, up, down, stretch, compress. It's just the very basic boring function. And if I plug in a negative number, you can't take the square root of a negative number and stay within the real number realm. I know we did imaginary numbers right after Thanksgiving break. We're not going to do that anymore, okay? Everything's going to be in the real realm. So that's why there's kind of this point where what's going to be under the radical sign is negative, and no, we're not going to do that. So that's why your graph always goes to the right. Now it is possible that it could go down and towards the right, but it will always go right. By the way, the domain then is always going to be x is greater than whatever kind of is down in there. We're going to talk about more about that. And then range is going to be x is either greater than or equal to or less than or equal to your starting point. Well, how can you find the starting point? That's where I'm really interested. When we transform these functions, this is the formula that we kind of use here. And you might notice some familiar friends, a, h, and k. And they continue to do the exact same jobs they have always done since we started doing A, H, and K. A will stretch or compress or potentially flip it upside down. H will move it left and right, but opposite of what you think. And K moves it up and down. This will help us determine the domain and range as well. Here's what I really want you to know from this page. H and K will tell you your starting point. So I say graph, you say table, and you're like, okay, well, where do I know, or how do I know where to start my table? HK will always be your starting point right at the top. So let's actually maybe try one here. Graph the function, then describe domain and range. So again, HK is your starting spot here. X, Y. Since this is a positive 4, and I know that H is opposite of what I think, this is actually going to be a negative 4. And then K, since there is no plus a number, that's just going to be 0. Also, another way that you could have potentially figured this out was just take what's underneath the radical sign, set it equal to 0. X equaling negative 4 is your far left value to put in your table. And then let's maybe do some more values. You want to move to the right on your graph, so that's why I'm picking these values here. I have already plugged these in previously, so I can go ahead and just fill in the table, which will save us a little time on the video. And now just do your very best to plot these. I understand you're not going to be able to plot 2.8 perfectly. Just do your best. Negative 3, 2, negative 2 and 2.8, 3.5, and 4. And connect the dots in a semi-smoothish curve. Just like that. So now your domain is going to be x is greater than or equal to, it's always greater than or equal to, and it's, well, the x value of your starting point here, negative 4. Your range then, it can change. It might be a less than, it might be a greater than. Since the graph appears to be going up, this is going to be a greater than or equal to, and then again, you just choose your starting point, which is 0, like that. Okay, so identify domain and range. I can identify a domain and range without even graphing it. because I know that if the A value, which would be right here, is positive, that means it opens up. And since there's not an A value, then I assume it's just a regular boring 1, which again is positive. So without even really making a formal sketch, I know that this thing looks like this. It's going up somehow. Next, I'm going to use, know what the vertex is. So I know that it is at 3, because it's opposite of what you think. And then 0. So I can do the domain by saying that x is greater than or equal to this value right here. And y is, since it goes up, it's going to be greater than or equal to this value right here. And I should probably label those domain and range, just like that. All right, 4a is an inequality with graphing. This is one of the ones where when you go to start your table, you're not going to be able to just say the 1 because of this 2 right here. That little kind of cheat that I was doing earlier only works if x is by itself. So what I'm going to go ahead and do is this setting of equal to 0. So 2x equals -1. My pen's not working well. Here we go. So that equals -1/2. And then I'll fill in the rest of my table, probably just with nice happy whole numbers. Now I've already plugged this information in, so I'm just going to go ahead and fill my table in. Oh goodness, this was a 6. I'm not sure what happened there. Okay, now as I go to connect the dots, this is where you again need to remember your dashed versus solid lines to kind of write that key for you over here. If it doesn't have the equal portion, it's a dashed line. If it does equal, then it's a solid line. Extra ink, extra ink. Since this one does have the extra, since it does equal, it is extra ink, extra ink. So when you go to shade this, there's kind of a rule here that you need to pick a point that is to the right of your starting point. Used to be I always said use 0, 0, but 0, 0 always worked for those previous graphs. This time, use a point that is to the right of your starting point. In this case, 0, 0 does work, but I'll choose 1, 1, just so that I'm choosing something different. And plug it into the original equation, remembering that points x, y, it's given to me in function form, but if you recall from that packet we did right at the beginning of the semester, I can pretend that that is basically just a y. So I'm just going to be plugging in some 1s then, both for the x and for the y. And let's simplify. And let's see, the square root of 3. It's a decimal. I'm not 100% sure what it is, but it's 1.4-ish or something like that. Okay. What I do know is what I have to do next is read this sentence. Is 1 bigger than 4? 1.4, I mean. And the answer is no. 1 is not bigger than 1.4, which means I cannot shade right there, which means you need to shade up. But here's the thing. I also know, here I'm going to go ahead and maybe color this in. I also know, though, that nothing in this area works because I can't have negatives underneath the radical sign. So that's why I won't be shading to the left of my starting point. You can kind of maybe draw like a vertical line up And then everything else can be shaded, but nothing to the left. That's it for this one.